Okay, this is Math 1090, Section 3.5, Applications of Linear Programming. In the previous section, we investigated the graphical method for solving a linear programming problem in two variables. Now we'll employ the simplex method, which can handle more than just two variables. While the simplex method can be done by hand via row operations on a special matrix, in this section, we will use computer software. We will demonstrate setting up the objective function and linear constraints in an Excel spreadsheet, and then interpreting the solution provided by Excel's simplex method functionality. Okay, so we're not going to do the simplex method by hand, but we are going to, in this section, cover two exercises, one on bike frames and one on shipping. Okay, but I want to just emphasize that this method, this linear programming method for solving optimization problems, has ubiquitous use cases. It can be used in so many different scenarios. Okay, a manufacturer of bicycle frames builds racing, touring, and mountain bike frames. The bicycle frames are made of both aluminum and steel. The company has available 9,793 units of steel and 7,430 units of aluminum. The racing, touring, and mountain bike frames need 16, 13, and 18 units of steel and 15, 9, and 14 units of aluminum, respectively. The company makes a profit of $22 per racing frame, $38 per touring frame, and $24 per mountain bike frame. How many of each type of bike frame should they produce to maximize their profit? So we want to maximize profit. So there's a little hint here. Let X denote the number of racing frames manufactured, Y the number of touring frames, and Z the number of mountain bike frames. Okay, so what we're going to do here is we're going to turn this into a linear programming problem by finding the objective function. We've already come up with our variables, X, Y, and Z, the number of each type of frame to produce. That's really the first step. And then you want to write your objective function. And finally, you need to write the system of linear of linear inequalities that your solution must satisfy. We call these constraints. So what would the objective function be? Well, we want to maximize profit, and well, we're told that they make a profit of $22 per racing frame, $38 per touring frame, and $24 per mountain bike frame. So what we need to do is just to get the total profit, this is just going to be the number of racing frames times $22 per frame. So that's going to be 22x. That's the profit from selling racing frames. The profit from selling touring frames will be 38y. And the profit from selling the mountain bike frames will be 24z. Okay, so there's our objective function. Next, write the constraints as a system of linear inequalities. Okay, so again, each inequality is going to be some kind of expression, a linear expression in x, y, and z, less than or greater than or equal to some quantity. And we need to glean those from the problem description. So it looks like that they only have a limited amount of both steel and aluminum. They have 9,793 units of steel, whatever unit of measurement they're measuring in, I don't know, and 7,430 units of aluminum. And let's see, it looks like the racing, touring, and mountain bike frames need 16, 13, and 18 units of steel. So if I multiply, let's see, 16 times X. That's going to give me the amount of steel I use from producing racing bikes. And then to that I add 13 times Y. That's the amount of steel I use creating touring bikes. And then 18 times Z. That's the amount of steel I use creating mountain bike frames. And then I have to make sure I use less than or up to 9,793 units of that steel. Okay. And also we're told that they use 15, 9, and 14 units of aluminum respectively, so we have 15x plus 9y plus 14z. That has to be less than or equal to, well, let's see, we have 7,430 units of aluminum. Okay, are there any other constraints here? Well, I think we've used all the numbers in the problem, so I don't think so. Of course, there's the constraints that x, I'll just write that down here, x, y, and z all have to be non-negative. Okay, there's an easy way to add that into Excel, we'll see. Okay, so part C asks us to use the solver add-in in Excel to determine the optimum number of bike frames they should manufacture in order to maximize profit. Okay, so let's open up a blank Excel workbook. Okay, so I'm going to create 3 sections in this workbook. I'm going to create a section for variables. Okay, and then let's see, the variables will be x, y, and z in this case. And for right now, I'm just going to say they're all 0. Okay. And then let's create a section for the objective function. Not objection, but objective. And the thing we're trying to maximize is profit. Okay, and okay, so how do I get profit? If we go back to the notes here, well, the profit function is 22x plus 38y plus 24z. So how do I encode that via the spreadsheet mechanisms? I'll show you. It's very simple. Wait, the numbers were 22, 38, 24. We got to remember those. Okay, so to put a function into a cell, you just you highlight the cell and then you start the cell with equals, an equal sign. Okay, and now you're telling Excel I want to start a formula. Okay, so I want to do 22 times x. I use the asterisk symbol for multiplication in Excel. So 22 times x. X is, well, I can just click on the cell that contains the value for x and it will put it right into the formula for me. And to that I want to add 38 times the number of touring bikes, which is the value for y. And then to that I want to add 24 times the number of mountain bike frames. Okay, and there we go. There's our objective function. Yeah. Okay, and notice if I go and change these numbers by hand and then hit enter, it will update the profit function for me. Like if we sell 2 touring bike frames, okay, now our profit is $98. Okay, so it's working. Okay, and now finally we want to put in our constraints. We have 2. We have this a steel constraint and the aluminum constraint. Oh, aluminum. I became British there for a moment. Okay. So what is our steel constraint? Let's go back to our notes. Let's see. It was 16x plus 13y plus 18z has to be less than or equal to 9793. Okay, you know what? I'm going to take these two, I'm going to take these two constants and put them right into my spreadsheet right now. 9793 and 7430. Okay. So let's see, I'm going to put those over in this column. 9793 and 7430. Okay, and now over here in this cell, I'm going to put in the, you know what, I might as well make this just a little bit bigger, so it's easier for everyone to see. Yeah, I guess that works. Okay, so let's see, I want to do equals, and then what is it? I want to do 16x plus 13y plus 18z. Okay, 16, 13, 18. So I want to do 16 times the cell that contains x, that's this one, plus 13 times the cell that contains y, that's this one, plus 18 times the cell that contains the z value, which is this cell, B4. Okay, there we go. Okay, and with the numbers we've got in there already, we would need 42 units of steel. Okay, what was the aluminum constraint? It was 15,914. Okay, so I'm going to start with an equal sign. So I want to do 15 times the x value plus 9 times the y value plus 14 times the z value. Okay, there we go. Hit enter, and there we go. According to make one racing bike and 2 touring bikes, I'd need 33 units of aluminum. Okay, you know, I sometimes might want to make things look a little nicer by doing something like this, putting maybe a little bit of color into my spreadsheet and making these look like headers or something. Okay, and we'll make this frame fit the text we've got there. Okay, and there we go. That's good, assuming we've put in everything incorrectly. Okay, now in order to have Excel do the linear programming, the simplex algorithm on this problem, I need to first install an add-in, and what's called an Excel add-in. Okay, now you don't have to download or anything. It comes with Excel. It's just not installed by default. So if you go to File in the ribbon, the File tab in your ribbon, and if you look at the very bottom there, it has Options in this vertical list of links. So click on Options, and it will bring up this dialog box. Okay, now in this dialog box, you see second from the bottom, it has Addins on this left-hand column of tabs in this dialog. Okay, so I'm going to click on Addins. Whoops, there we go. Okay, and then this thing here at the top, notice I've got the solver add-in. I've already installed it because I did this ahead of time, right? You probably won't have that installed unless you've done unless you've used the solver before. You probably won't have it installed. And so to manage Excel add-ins, just make sure it's Excel add-ins there, and this little, you see the little manage drop down at the very bottom here, and then the go button afterwards. Just click on go, and it brings up this dialog. And what you need to do is make sure that that solve or add-in checkbox is checked and then hit OK. And it will actually install it if you haven't installed it before. Okay, so that's it. And now when you go to the Data tab of the ribbon, you'll see over here on the far right, it says there's a little question mark and arrow icon and the word solver in the Analyze column over here on the far right of the Data tab of the ribbon. Okay, once I've entered in all of this, all of my objective function and all of my constraints, I can go now to the solver. Okay, and I'm going to have to tell it where each of these things reside in this spreadsheet. So the objective function, that resides in cell B7. So you want to make sure your cursor's in there, in the objective input box there. And then you can just click, you can hit the arrow here and it will allow you to choose. I'm going to click on cell B. Oh, wait, I just want cell B7. So let me just hit. There we go. Okay. Okay, so now I've set the objective function. Now, what do I want to do? Do I want to maximize it? Do I want to minimize it? Do I want it to find a particular value? I want to maximize my objective function, profit. Okay, and now I've got to change it or tell it where the variable cells are. What are the cells that contain the values that it can change? Okay, they're in this B2, B3, B4, right? Those are our variables. Okay, so I just click on this little arrow here and then I select cell B2 and then I hold the shift key down and select the last cell. Okay, and there we go. I want that whole range. Enter, and there we go. I've got the range from cell B2 to B4. Excellent. Okay, now we've got to add our constraints. Okay, our constraints are down here in cells B10 and B11 and C10 and C11. Okay, I want to add a constraint for the steel. So I hit the add button and I want to reference the steel. I don't have to hit that arrow. I can just click the cell with my pointer device, whatever I'm using. Now I want this to be less than or equal to the total amount of steel that we have, 9,793 units. So my constraint is in this cell. It's in cell C10. Okay. And now I want to add another constraint, so I'm going to hit add. And then my next constraint is the aluminum one. It references this cell B11. Okay, and I want that quantity to be less than or equal to the quantity in C11. Okay, and now I'm done. I'm just going to hit OK. And there we go. We see the constraints are now in the dialog box there. And there's this little check box. Make unconstrained variables non-negative. So this would be like saying that adding the constraint x is greater than or equal to 0, y is greater than or equal to 0, and z is greater than or equal to 0. So yeah, we want to check that in this situation. Next, select a solving method. There's 3 methods that Excel has. We're going to use the simplex LP, LP for linear programming. Okay, and now we are all set up. There's some options you can choose. I'll show you those in just a minute. But now you just hit the solve button. Once you got everything set up correctly, you hit solve, and there we go. We'll keep the solver solution. Our solution is we should make 753.3 touring bikes, right? Y was the number of touring bikes. And when we do so, we'll make a profit of $28,625.69. Okay. But notice we really can't make 753.3 bike frames, can we? So really what this is an integer programming problem. We want only integer solutions. So there's a simple way to tell Excel that. So I'm going to click on Solver again. And what I'm going to do is I'm going to add some new constraints. Okay, so I'm going to click on the Add button here. And I'm going to reference the cell B2, which contains the value for X, the number of racing bike frames. Okay, and then I'm going to click on this less than or equal to. You can change this to greater than or equal, or integer, or binary, or I don't know what DIF stands for, but integer is what we want. Okay, so the constraint is that cell number B2 has to contain an integer. Okay, we want to do the same things now for Y and Z, so I'm going to hit Add. I'm going to click on the cell that contains our Y value, click on the middle drop down and change that to integer. It has to be an integer. I want to add one more constraint. I want to change Z's value, which is contained in cell B4, and I want to change that to be an integer as well. And then I'm done adding constraints, so I hit OK. And now you see we've got these three new constraints. B2, B3, and B4 all have to be integers. Okay, so it's actually an integer version of the linear programming problem that we want to do. And we hit Solve and OK. And yeah, it's now changed it so that we're only making an integer number of bike frames, of the touring bike frames. Okay? All right. So there we go. Notice, I want to just demonstrate to you how sensitive this can be to your profit function and your constraints. So I'm going to go in here to the profit function, and let's see here. What if we change the profits? What if we change the profit? Maybe our touring bike frame model, we can't sell it for as much. Maybe the price drops down to $36. And then, maybe our mountain bike model, though, goes up in value. Maybe it jumps up to $28, and maybe our racing frame jumps up to $25 per frame. Okay. So this is kind of fun. We can explore, right? We can do what-if scenarios with this spreadsheet. Now I just hit Enter and go to the solver again and hit Solve. Wow. Okay, that really didn't change anything. I guess our touring bike frame is a real winner. It is really the thing that we're making our most money on. So that's really what we should focus on. I wonder how much you'd have to change the profit function. Let's really drastically reduce the profit from a touring bike frame. Let's change $36 of profit down to, say $26. I'm sure this will change things now. Okay, hit Enter, Solver, Solve. No, it did not. Wow. It's still by far and away the best. Why is that? The steel... Oh, it really uses very little steel and very little aluminum. Oh, that's why. It uses far less steel and aluminum than the other models, and it still makes... Okay, so let's just really crush the profits down to $16 and see if that changes it. I'm sure this will. Okay, Enter, Solver, Solve. There we go. Okay, now we see that we should only make one touring bike and we should make 530 mountain bike frames. Okay, so anyway, you get the idea. You can play around with this spreadsheet, and as your constraints evolve over time in your business, you can change this spreadsheet to help you manage your business. Okay. Let's move on then to the next problem. Okay. So we have a distribution company needs to ship products from its 2 warehouses to 3 retailers. Warehouse A has 1,000 units of product, and warehouse B has 1,200 units of product. Okay, retailer 1 needs 700 units of product, retailer 2 needs 500 units, and retailer 3 needs 600 units. The cost in dollars to ship 1 unit of product from each warehouse to each retailer is shown below. Find the number of units of product the company should ship from each warehouse to each retailer to minimize shipping costs. Okay, so this is a logistics type of problem. Companies like Amazon encounter this very problem every single day of business, don't they? Okay. Other companies like FedEx and UPS face very similar types of problems. A little different, but very similar. Okay. So we have 2 warehouses, and we need to distribute product from these 2 warehouses to these 3 retailers. Okay, and we're just, notice this is just, we're just thinking about a single product. If you were a grocery store supply chain, if you were in charge of a grocery store supply chain, imagine how much more complicated this would be. You would have thousands of products, probably dozens of warehouses, and maybe hundreds of retailers. Okay, so it could get very complicated, but the simplex method is very robust and can handle all of that. Okay, so it gives us some hints on what to use for our variable names. That's always nice. And these are, I think, are particularly good variable names. So we're going to let A1 denote the units of product shipped from warehouse A to retailer 1. Okay, that makes sense. A to 1, right? And B sub 1 denote the units of product shipped from warehouse B to retailer 1. And then, of course, A sub 2 will denote the units of product shipped from warehouse A to retailer 2, and B sub 2 will denote the units shipped from warehouse B to retailer 2, and then so on with retailer 3. Okay, so our first goal is to write, again, in normal situations, you would have to come up with the variable names on your own, okay? But it's kind of nice to use these A1s, A2s, and B1, B2, B3 because they line up perfectly with the names of the spreadsheet cells. So these are particularly nice names here. Okay, write the objective function. Well, let's see here. What do we want to do? We want to minimize shipping costs. So our objective function is a cost function. Cost. And let's see, it's going to cost, it costs $3 to ship 1 unit of product from warehouse A to retailer 1. And how many units of product are we going to ship from warehouse A to retailer 1? We're going to denote that with A sub 1. So if we do 3 times A sub 1, that's going to give us the cost to ship from warehouse A to retailer 1. And then we need to add in the cost of shipping from warehouse B to retailer 1. So that's $4 according to the table. 4 times B1. Okay, and then what about the cost? So that's the total cost to ship product from both warehouses to the first retailer. Now what about shipping to retailer 2? Well, we're going to have 5 times A2 plus 7, and I'm just getting these now from this column here, plus 7 times B sub 2, right? Let's just make sure we understand exactly what this is saying. 5 times A2, that's the cost to ship A2 units of product from warehouse A to retailer 2. Okay? For each unit of product, we have to pay $5 in shipping fees. And then over here, for each unit of product we ship from warehouse B to retailer 2, it costs us $7. Kind of pricey. Now, finally, what about shipping to retailer 3? We're going to do, now I'm just using this column, we're going to do 8 times A3 plus 5 times B3. By the way, I should note that this problem comes from your textbook, and in your textbook, the table has that digit wrong. The textbook has a 6 there, but I've corrected it. It is an 8. The problem in the textbook uses an 8 there, but so I'm matching what the textbook does. Okay, that's our objective function. Now, what are the constraint inequalities? Well, let's see. Let's reread the problem. It looks like warehouse A only has 1,000 units of product and warehouse B has a limit of 1,200 units of product to ship. So we have a constraint for each warehouse, right? The amount that warehouse A can ship out is limited to 1,000 products, and the amount that warehouse B can ship out is limited to 1,200 products. So let's see. So we have a warehouse A constraint and a warehouse B constraint. What is the warehouse A constraint? It's going to be well, A1 plus A2 plus A3 will be all of the product that warehouse A ships to all the retailers. So that needs to be, so this sum, A1 plus A2 plus A3, this needs to be less than or equal to what they have, the product on hand, which is 1,000 units. Okay, now similarly, the amount that B can ship out, that's going to be B1 plus B sub 2 plus B sub 3, and whoops, and this must be less than or equal to 1,200 units. Okay, are there other constraints? Let's reread the problem. So we've used this number, that number, we've used all of these numbers. Oh, but we haven't used these numbers yet. Retailer 1 needs 700 units of product, retailer 2 needs 500 units of product, and retailer 3 needs 600 units of product. That's probably 3 more constraints, right? Let's see, so we have a retailer 1 constraint. Let's see, so what are the amounts that get shipped to retailer 1? That would be A1 plus B1, right? So this A1 plus B1, this should be, well, ideally it would probably be equal to 700. But they probably wouldn't mind getting more. I don't know, but let's put it in that way. It's got to be at least 700, right? And then we have retailer 2. That's going to be A sub 2 plus B sub 2. This has to be greater than or equal to, I think it was 500. Yeah, 500 and 600. This has to be greater than or equal to 500. And then finally, retailer 3. This would be A sub 3 plus B sub 3. This has to be greater than or equal to 600. Okay. And of course, A sub I and B sub I, these variables all have to be non-negative. So really that's 1, 2, 3, 4, 5, and another 6. So 11 constraints in total for this linear programming problem. That's not uncommon. Okay, now we need to take this written description of the linear programming problem and translate it into an Excel spreadsheet, and then use the solver. Okay, I'm going to start, and you know what, I should probably name my sheets now. This one was the, let's see, can I just, no. Rename, we'll call this maybe bike frames. Okay, and then we'll do another spreadsheet here, and we'll name this one, whoa, that's not what I want. I just want to rename. Rename this one to shipping. Okay. Okay, now, like I said earlier, using the variable names A1, B1 through A3, B3 is really nice because that's just these cells, oops, that's just these cells in the spreadsheet, right? A1 through A3 and B1 through B3. Okay, so I'm just going to leave those, you know, I'm going to fill all of those with 0 right now, and zero, enter, 0, enter, 0, enter, 0, enter, 0, enter. Okay, okay, and then here we'll put our objective. Okay, and our objective function is a cost function. And this will be equal to what? This comes from that table of shipping costs. Okay, so it's here in part A, the objective function there. So it's 3A1 plus 4B1. So this is going to be 3 times A1 plus 4 times B1 plus, let's go back, 5 times A2 plus 7 times B2, 5 times A2 plus 7 times B2. Oh, you know what? I should make this a little bit bigger as well. Oh, I'll finish the formula and then I'll make it bigger. So, okay, now we got to do plus, and then 8A3 plus 5B3. So 8 times A3 plus 5 times B3. Enter. Okay, now I can change the zoom to, say, oh, we'll do 150%. Okay. Okay, there we go. There's the cost function. That's our objective. Next is our constraints. We have the warehouse A constraint. We have warehouse, we have warehouse B, and then we have retailer 1. We have retailer, I don't know how to use this. Retailer 2, nope, 2, and retailer 3. Okay, let's make this column wide enough. Okay, I'm going to put the constants in this column here. So warehouse A only had 1,000 units to ship, right? Yep. And warehouse B had 1,200. So 1200 goes here. Retailer 1 wanted, was it 700 units? Yeah, 7, 5, and 6. So 700, 500, and 600. Okay, now let's go ahead and put those constraint functions in. Warehouse A, this one was just A1 plus B1 plus, sorry, A1 plus A2 plus A3. So this is equal to A1 plus A2 plus A3. And then warehouse B, this is going to equal B1 plus B2 plus B3. Now, if you had a much larger spreadsheet, you could use like the sum function or something, you know, to do this. Obviously, you wouldn't just poke them, click on every single individual cell by mouse and select them all if you had 1,000 rows or something to add up. But I'm just doing this. This is a small spreadsheet, so let's see. Retailer 1 is going to get products from both warehouses A and B, so this will equal A1 plus B1, right? And then retailer B's constraint will equal A2 plus B2, and then retailer 3, this will equal A3 plus B3. All right, let's go and just maybe change a couple of these values just to check to see if our spreadsheet is working. Does this seem to be working? Okay, yeah, it seems to be changing up costs and how much each retailer is getting delivered, etc. Okay, good. Okay, I think we're all set. Maybe just make this a little bit more, nope, go to home, make this more like a header, and constraints. Okay, I don't have a section for variables here because, well, because I just want to take advantage of the cell structure of the spreadsheet. My variables are at the top. Okay, I'm all ready now. I'm all set up to use the solver. So I go to the Data tab of the ribbon and click on Solver in the far right Analyze column there. My objective function is in cell B5. I don't want to maximize this time. I want to minimize. And if you recall, one of the theorem of linear programming says that if you have an unbounded region, which is what we have here, then as long as the coefficients of your objective function are positive numbers, then you can minimize it. And we do. Our objective function had all positive coefficients. Okay, what are the variable cells that we're going to change? Well, we're going to change from A1 here down all the way to over to B3. Okay, and now let's add a constraint. The first one will be the warehouse A constraint. Yeah, this has to be less than or equal to this value, 1,000. They only have 1,000 units. Okay, let's add a new constraint. This will be the warehouse B constraint. That has to be less than or equal to the value in this cell, 1,200. Okay, let's add the retailer 1 constraint. That's this cell. That has to, and now we want to change this to greater than or equal to the value in cell C9. Okay, we got to add, oops. Okay, next one is B10. So retailer 2, that's B10. That has to be greater than or equal to 500, which is this cell, C10. Okay, I want to add one more constraint. Retailer 3, the amount of product they get should be greater than or equal to 600, which is Oops, I chose the wrong symbol there. Oops. Greater than or equal to, I don't want integer, I want this cell, C11. All right, I think we're all set. I do want to make sure that checkbox is checked. And, oh, I do want to change the solving method to the simplex linear programming. There we go. And I think we're good. We got 5 constraints in there plus our 6 non-negative constraints. We've got this changing variable cells will be A1 through B3. Yep, and our objective is in B5. And we want to minimize it. Okay, please solve. All right. So our solution is up here in the whoops, come on. In these cells right up here. So this means, what do these mean? So the first cell, A1, remember A1 is the number of units shipped from warehouse A to retailer 1. So retailer 1 is going to get 500 units of product from warehouse A, and they're going to get 200 units of product from warehouse B, which is good because they wanted 700 units of product. Okay, now if we look at the second row, that's going to tell us, we add those two up, 500 plus 0, that's 500, and that gives us what? That gives us the amount of product that retailer 2 needs. Yep, 500. And then if we add up the final 2 rows, A3 and B3, that's going to give us the amount of product that retailer 3 will get, which indeed should be 600. So perfect. There we go. So our answer is what is our answer? We'll write it down here. A1 equals 500. B1 equals 500. No, 200. A2 equals, I believe this was 500, right? Yeah. 500. And B2 was 0. So retailer 2 is getting 0 product from warehouse B. And then retailer 3 is getting all of its product from warehouse B. So A3 equals 0, but B3 equals 600. Okay. And this concludes section 3.5 on linear programming.